Okay, we're now on to solution of trig equations, and these are using our sec, cosec, and cot functions as well. So we have to use our knowledge of these ratios. So we should remember that cosec, not doing these in any particular order, but cosec is 1 over sine x. Sec x is 1 over cos x, and cot x is 1 over tan x. So for the first one, we've got sec x and cot. So they're two different trig functions, really. So what I'm going to do is just rewrite my sec x as 1 over cos x is equal to 2 cos x. And then what I'm going to do is just multiply across that. So 1 is equal to 2 cos squared x, which means cos squared x is equal to a half. So cos x then would be equal to plus or minus the square root of 1 over 1/2. So square root of 1 is 1, square root of a half is root 2. And then we're on to our basic angle thing here. So the basic angle of that is going to be equal to, so ignore the plus or minus, just do cos to the minus 1 of 1 over root 2, and you're going to get 45 degrees. And then we will do our cast diagram, C, A, S, and T. Very important example here. I'm just going to mark on my 0, my 180 degrees, and then we're back to 360 degrees. Now, where on earth do we put our 45 degrees? Which quadrants does it go into? Now, if you look back to your cos, when we got to here, cos is both positive and negative. So in this case, it's a bit of a strange one, but in this case, your angle goes in the all quadrant, where everything is positive. It goes in the C quadrant, because my cos is positive in here. And it goes in the S quadrant, because our cos is also allowed to be negative. And it goes in the, sorry, this pen's playing up. It goes in the T quadrant, just like the last one, because the the cos is allowed to be negative. So your angles are as follows: 45 degrees working anti-clockwise. 45 degrees is the first one you come to. Then 135 degrees. Then it's going to be 225 degrees. Then it's going to be 315 degrees. So you've got 4 angles, and just check all 4 angles are within my range, so my original range, so they're fine, and that's it. Okay, this next example says solve 3 plus 3 cot squared x plus 2 cot equals 4. So first thing I'm going to do is tidy this up a wee bit, bring everything out over to one side, put it equal to 0, and write the quadratic terms first. I'll have 3 cot squared x plus 2 cot x, minus 1 is equal to 0. So this factorizes, my sum is equal to 2, my product is equal to minus 3, so my two numbers are minus 1 and, nope, that's nonsense. They're not minus 1 and minus 3 at all. They are minus 1 and plus 3. Just change that to a plus there. Okay, so we'll rewrite our equation. It's going to be 3 cot squared x minus cot x plus 3 cot x minus 1 equals 0. So take a cot x outside a bracket to leave me 3 cot x minus 1 plus 1 times 3 cot x minus 1 equals 0. So that's 3 cot x minus 1 upon cot x plus 1 is equal to 0, which means the first bracket is equal to 0, which means cot x is equal to 1/3, or else the second bracket is equal to 0, which means cot x is equal to minus 1. Okay, notice in your calculator you do not have a cot function, but you have a tan function. So convert these back to tan. So tan then would be equal to 3, or over here, tan x would be equal to minus 1. So I've just done reciprocal 1/3, so turn it upside down to give you 3, reciprocal -1, turn it upside down, or turn it over, put it over 1, and to give you, or put 101 to give you -1. Okay, running out of space there, I'll write that again. I'll do my tan is equal to, tan x equals 3 first of all. So do your basic angle of that, and I got 1.25, and that's radians. And then we have to draw your cast diagram. Remember, it goes from 0 all the way around to 2 pi, and tan is positive, so it goes in here. So 1.25 radians goes in here. It also goes in here, 1.25. And then you can get your two angles are going to be x is equal to 1.25, radians that should be. And the other one is going to be pi plus, so that would be all the way around to here would be pi. And you've got to go another 1.25, so that's pi plus 1.25. That's going to give you 4.39 radians. Okay, the other one we've got to do, what did we have for it? We had tan x is equal to -1. So tan x equals -1, the basic angle, and that's a nice one, it's pi over 4. So you can do your cast diagram again, C, A, S, and T. And tan is equal to, tan was negative, so negative quadrants for tan are in here and in here. So mark in your angle always with the horizontal, remember, so pi over 4 with the horizontal. So the first angle is round to here. The second angle is all the way around to here. So my answers, first one's going to be pi over 4 short of pi, so that's going to be pi minus pi over 4, which is going to be 3 pi over 4. And the next one is going to be 2 pi, sorry I didn't mark those on, 0 and 2 pi, so it's going to be pi over 4 away from 2 pi. Do that on your calculator and it will, if you just do 2 pi minus pi divided by 4, and it should give you 7 pi over 4. Okay, your answer then, just tidy that up, just write them all together. So your answer, I have 1.25 radians. I have got 3 pi over 4 radians. Next one I've got is my, where did we go? It was the 4.39 radians, and my last one is my 7 pi over 4. It's maybe not very obvious where I'm getting those from in ascending order, so just go through. As you come round, go round the circle here. The first one I come to, this one's in the first quadrant, so that's why it's first. This one's in the second quadrant, that's why it's the second one I come to. This is in the third quadrant, that's the third one overall I come to. And this one will give me 4.39, and this one was in my last quadrant, so it's my last one that I found. Okay. Okay, great example here. It says solve sine 2 theta is equal to root 3 over 2 for 0 is less than or equal to theta is less than or equal to 270. I'm just going to write that again. Sine 2 theta is equal to root 3 over 2, and that was for 0 is less than or equal to theta is less than or equal to 360. Now notice my angle is not theta, it is 2 theta. So that means you've got to adjust your range. So instead of theta, you write 2 theta, and that means your 0 also gets multiplied by 2, still stays as 0. The 360 also gets multiplied by 2, so it goes to 720 degrees. So we're now on to doing this, and basic angle then is going to be equal to, so sine to the minus 1 of root 3 over 2, and it's going to be 60 degrees. Now, up until now, I've been labeling my axes. I don't want you to label your axes here because it saves you drawing out two things, but we do want to put in where our angle goes. So it's 60, and sine's positive, so it goes into the A and the S, so it goes in here, and it goes in here. Well, use your imagination, they're both the same angle, we're going to pretend. So there's 60 and 60. So our angle is now 2 theta. So you're saying 2 theta equals, and we're going to have to go around this one full revolution to get the 360, and then again to get to the 720. So going around the first time, the first angle we get to is just 60 degrees. Okay, start back to your 0. Next angle you get to is, that's going to be 60 degrees short of 180, which is going to be 120 degrees. And then it's the same two angles again, but you've just added 360 to them again. So 60 plus 360 is going to be 420. And then 120 plus 360 is going to be 480 degrees. Okay, you're not quite finished. That was what 2 theta was equal to. So it's just a four linear equations really. So therefore theta is equal to 60 divided by 2 gives you 30. 120 divided by 2 gives you 60. 420 divided by 2 gives you 210. 480 divided by 2 gives you 240 degrees. Okay, good example here. It says solve sec of 2 theta minus 45 is equal to 2. So to do this, what I'm going to do first of all is get rid of the sec, change it from sec. Sec is 1 over cos. So if I reciprocal the left hand side, I'm going to get cos of 2x minus 45. So I've reciprocal the left hand side to get back to cos, so I must reciprocal the right hand side, so it becomes a half. And if you do your basic angle, so your BA, so cos the minus 1 over half, you're going to get 60 degrees. Okay, we also have got to sort out the range. The angle here is 2x minus 45. So I'm going to change my range to the middle bit of that inequality, I should say here, goes to 2x minus 45. So what I'm going to do to my 180 is multiply it by 2 and then take away 45, and that's going to give me 315 degrees. What I'm going to do to the 0 is multiply it by 2 and then take away 45, so that gives me 45 degrees. So I've adjusted my range here accordingly. So now we want to go and draw your cast diagram, and I definitely would not want to be putting anything onto the axes here. Just mark on your CAST. Our angle was 60 degrees. Cos is positive, so it goes in here. Oh, sorry, it goes in here, which is 60. And it goes in here, which is 60. So, I'm not really too sure which ones it's going to be here. So we're going to go round all the way around here and see. If I go back the way, that would be back away from 0. That would be minus 60. So it's outside that range. So that really hasn't been an awful lot of help to me here. So my two angles I'm going to get are if I go forward. So from here, from 0 up, that's going to be my first one is going to be 2x minus 45 is going to be 60 degrees. And my next one is going to be all the way around, and that would be at 300 degrees. So it's 60 short of a full turn, so it's 300 degrees. And have a wee look. They are both within the range that we had, minus 45 to 315, so they're both good. And then what we do is solve these. So we'll take a couple of steps to do this. First thing I'm going to do is bring the 45 across and add it on to both my answers. So that's going to go up to 105, and then the next one's going to go up to 345, I should say. And my last thing to do is divide through by 2. 105 divided by 2 is going to be 52.5 degrees. 345 divided by 2 is going to be 172.5 degrees. And have a look. Both of these are within my original range, which was between 0 and 180 degrees. So it looks to be correct. Okay, questions you can now do are topic 5 and exercise 2 and questions 7 to 10.